Hello, students, and welcome to our lesson on dimensional analysis. Dimensional analysis is what allows us to convert from one unit of measure to another. So our first bullet point there, dimensional analysis is the process of converting from one unit of measure to another. And in general, we kind of have to do this a lot, if I'm being honest. So dimensional analysis is something that we tend to do without ever giving it a formalized name. So anytime you're converting from days to weeks or from minutes to hours or from rotations to distance, just really converting between any two forms of a unit, you're doing dimensional analysis. You might just not have formalized it with such a name. But today what we're going to do is we're going to really go deep into the examples and we're going to look at a whole bunch of different units that we might want to convert between. So within the metric system, most conversions can be made by multiplying or dividing by a power of 10, which means the decimal moves to the left or the right. But within the standard system, most conversions require multiplying or dividing by a number that is, well, not a power of 10. So it means it's not as simple as just moving the decimal place to the right or left. So instead, we're going to have to know some actual conversions between units, which is what makes the standard system harder for most people, is you have to remember more, not just the prefixes that we saw in the metric system, but you have to remember all these different conversion amounts. All right, converting from metric to standard or vice versa will also require multiplying by numbers that are not powers of 10. So if we're trying to go from the metric system to the standard system or the other way around, usually those conversions are not super clean, not as easy as just moving the decimal place. And then converting using dimensional analysis will specifically require multiplying and dividing by what are known as unit fractions. Okay, unit fractions, where the word unit means one, and a fraction, we of course know, is a number over another number. So the idea of a unit fraction is to have a fraction that is equal to one. So our next bullet point down there, what are unit fractions? Well, a unit fraction is a fraction in which the numerator and denominator contain equal amounts in different units. So the idea is that although the numerator and denominator might not look like they're the same thing because they have different units, they do in fact represent the same quantity. So for instance, we might have 1 foot over 12 inches, where we know that 1 foot and 12 inches are the same thing. And so this fraction is actually just equal to 1 because we have the same thing on top and bottom. We have equal values on top and bottom, making it a unit fraction. It is worth 1. We might have instead 365 days over 1 year, where 1 year, 365 days equal to each other. We might have $1 over 4 quarters. Okay, again, $1.04, the same thing. And we can also have all of these fractions upside down. So just as an extra example here, even though we saw that 1 foot over 12 inches is a unit fraction, we could also have it as 12 inches over 1 foot. And that is an equivalent fraction where we just have a different numerator and denominator. We did the reciprocal of that fraction. Because remember, the reciprocal of 1 is just 1. It doesn't change anything. So now we're going to use these unit fractions to essentially cancel out units as we do dimensional analysis. So all dimensional analysis really is taking a beginning set of units and multiplying by unit fractions until we get to the new set of units that we want. So these fractions you just saw examples of, that's all we're really doing in dimensional analysis is multiplying by fractions that are equivalent to 1, unit fractions. So now how do we use them? Always start with the given measurement. So we want to make sure that we know what we have. So when we say always start with the given measurement, we're specifically want to make a note of use units. Okay, we want to make sure that we don't just write down a number, we write down a number with units because those units are going to tell us what we need to be multiplying by, which unit fractions we need is going to be based on the units that are given in the original problem. If it isn't already, make it a fraction by putting it over 1. Okay, so if we are not given a fraction, if we're given a whole number, we'll just write it as being over 1. So for example, 8 is the same thing as 8 over 1. The reason we do that is when we multiply by unit fractions, we want to have numerators and denominators all the way across. That way it's very clear to see what we're actually multiplying by. Okay, then we're going to multiply by a unit fraction. And the point of the unit fraction is to connect the units that you want to get rid of with the units you want to convert to. So the key here is whatever we want to get rid of and whatever we want to convert to, those are what need to be in the unit fraction. So if I want to go from feet to inches, I want to make sure that I multiply by a unit fraction that will get rid of the feet and include the inches. Okay, so the whole point of unit fractions is to cancel out one unit and apply a new unit. All right, then we're going to make sure that the units we want to get rid of are on opposite sides of the fraction. So if we have a numerator that has feet in it, we would want to make sure that the denominator of the next unit fraction has feet in it to cancel out that unit. So for example, feet over 1 multiplied by 1 over feet, the unit of feet here would cancel to just leave us with 1. Now, in that case, we don't end up with a new unit, okay? But the idea is just to have units cancel. So when we're doing the actual problems, we're going to only use unit fractions. But the idea of that bullet point there is make sure that whatever unit you're trying to cancel with is in the opposite side of the fraction as the unit that you already have. So if you have feet in the numerator, you need to put feet in the denominator in order to cancel it out. All right, then once we have all our unit fractions set up, then we are just going to multiply straight across the top and across the bottom. So all the numerators multiply, all the denominators multiply, and then we will divide whatever is left over because we'll just have one number over one number. And the only remaining units should be your desired units. So all of the other units in the problem should have canceled out so that we're left with just the units we want. All right, so now let's do some examples so we can see what all this means. Number 1, a surgical thread is 1,250 millimeters long. Convert this length to meters. So in this case, we are staying within the metric system. So this will just be a refresher on what we did in the previous topic. We want to convert millimeters to meters. So we always want to first write down what we're starting with. So in this problem, we're starting with 1,250 millimeters. So I'm going to say 1,250, and millimeters is mm. Now, our next bullet point said if it is not a fraction, then we're going to make it a fraction. So even though I don't have a denominator here, I can write 1 as my denominator to turn this into a fraction. So now, I like to always think of my goal as the next step. So our goal is to not end with millimeters, our goal is to end with meters. So at the end of my problem, I want to get something that has meters, or m, as my unit. So that means somewhere in the middle, I need to cancel out millimeters. That way I only have meters left. So what I'm going to do is I'm going to multiply by a unit fraction that will cancel out millimeters and put meters there. So I'm going to write a numerator and denominator here. The key is to make sure that whatever unit you're trying to cancel actually cancels. So since I have millimeters on top right here, I have to write millimeters on bottom. So I'm going to put mm in the denominator. That way millimeters on top will cancel millimeters on bottom. And since I want to end with meters, I need to make sure that meters is in the numerator right here. So I'm going to put meters on top. Now for the numbers, all you have to do is make sure that you have a unit fraction. So make sure that your fraction, your numerator and denominator, are equivalent to each other. So we have a little note there with the asterisks is that 1 meter is equal to 1,000 millimeters. So here, I'm going to put 1 meter on top and 1,000 millimeters on bottom. What happens now is that the millimeters and the millimeters will cancel each other out, one on top, one on bottom. Those units cancel. And then on the top, I multiply 1,250 times 1, which is just 1,250. And on bottom, all I have is 1,000. So my fraction that I get as the result is 1,250 over 1,000. And let me just write the m here on the side. So then I just want to make sure I actually simplify this result. Dividing by 1,000, all that's going to do is move the decimal place because we were in the metric system. So that's all we needed to do from the beginning was move the decimal place. When we divide by 1,000, I move it 3 spots. So 1.250 meters. 1,250 millimeters is 1.250 meters. All right, so that one was pretty easy because we stayed within the metric system. Some of them will be that easy, and some of these are going to be a little bit more complicated. So let's keep going. A patient must receive 2.4 kilograms of IV fluid over 8 hours. Convert the mass to grams. So we want to convert kilograms to grams. So the first thing I'm going to do is write what I started with, 2.4 kilograms. So 2.4 kgs. And since it's not a fraction, I'll write it over 1. Then I like to write what I'm going to end with next. So I need to end with grams. So on the other side of this thing, I'll put a G for grams. And now I need to put a fraction in the middle that will cancel out kilograms and give me grams. So my fraction needs to have grams on top and kilograms on bottom. That way this unit of kilograms is going to cancel. But I need to put the numbers in. I need to make sure that my fraction is equivalent to 1, so it's a unit fraction. So 1,000 grams goes on top and 1 kilogram on bottom. Now, if you notice, all I have to do is multiply 2.4 times 1,000 because the denominator is just 1. When I do that multiplication, 2.4 times 1,000 is 2,400 grams. All right, number 3. Now we got a little bit more interesting one. We have 60 miles per hour, and we want to convert it to feet per minute. So the first thing we need to do is write down 60 miles per hour. The word per in math tells us to divide. Okay, so 60 miles per hour is 60 miles divided by 1 hour. Okay, so 60 miles per 1 hour is what 60 miles per hour means, is that in 1 hour, you go 60 miles. So this right here is also, in a sense, a unit fraction where we know that in 60 miles, we go 1 hour. Okay, but this is expressed as a rate. Miles per hour is known as a rate where you're doing a job, you're going 100 or you're going 60 miles and you're doing that job in an amount of time, and this time is 1 hour. So now we want to convert this to feet per minute. So on the other side of my equation here, I'm going to write feet over minutes, where notice I write a fraction as my result because feet per minute, that word per tells me I'm going to end up with a fraction. So now, notice my units, miles and hours, feet and minutes. Neither of them are the same. So in the middle, I need to cancel out 2 different units. I need to somehow turn hours into minutes, and I need to turn miles into feet. So we need 2 different conversions. Both of them are given to us there. We need to cancel out miles and turn it into feet. So since I want to end with feet, I'll put feet on top. And I want to cancel out miles right now, so I'll put miles on bottom. That way miles and miles will cancel, and I'll be left with a unit of feet. Now, I need to put in the numbers. How many feet are equal to 1 mile? Well, I have the relationship there. 1 mile is 5,280 feet. So I just make sure that I put the 5,280 with the feet unit and the 1 with the mile unit. So I have a fraction that is worth 1. Top and bottom are equal. Now I need a second fraction to convert hours to minutes. So since I want minutes to be on bottom, okay, notice minutes is in my denominator over here. I need to put minutes in the denominator of this fraction. Otherwise, there's no way it's going to get on bottom later, so I need to put it into the denominator now. I also have hours as my current unit in the denominator, So I need to put hours in the numerator over here. That way the hours units will cancel. So I'm going to have hours on top, minutes on bottom. That'll cause hours to cancel. And then now we just got to fill in the numbers. 1 hour is 60 minutes. 1 hour, 60 minutes. So now I can multiply across the top and across the bottom. Notice that I have 60 on top and on bottom. So although I could multiply everything on top and then divide by everything on bottom, because I coincidentally here have a 60 on top and a 60 on bottom, those are actually also going to cancel each other out. And so the only number I actually have left is 5280 on top and 1 on bottom. So 60 miles per hour is equivalent to 5,280 feet per 1 minute. And if you're not sure if that actually checks out, like that might feel strange, well, let's think about the fact that 60 miles in 1 hour, that's 1 mile per minute, right? Because 60 miles in 1 hour, an hour is 60 minutes, so this is 1 mile per minute. So over here, my answer should also be equivalent to 1 mile per minute. And notice I have 1 minute on bottom, and on top, 5280 is equivalent to 1 mile. So I also have 1 mile per minute is that ending amount. So we can do dimensional analysis also to just clarify if our answers are equivalent by thinking of the starting and the ending units in different terms. So these unit fractions I used in the middle, we can also use those to help us understand what our answer actually represents. So both these 60 miles per hour and 5,280 feet per 1 minute, these are definitely equivalent. All right, I'm going to leave the you try ones for later. So I'm going to skip those for now, and I'm going to go to number 4. I do highly encourage you to try those now, though, and then I will come back at the end and make those the last ones I do. So I'm going to go to number 4 first. It says convert 3.5 cups to liters. And we have here that 1 cup is approximately 0.24 liters. So we're going to write our starting units first. We have 3.5 cups, so 3.5 C, and I'll write this over 1 because we don't have a denominator. We want to end with liters, so I'll write L as my ending unit. So now in the middle, I need to do something that will cancel out C. So I'm going to put C in the denominator of my unit fraction. And I need to end with liters. So I'll put L on top. Now I just have to make sure I fill in numbers that make a unit fraction. So I have the conversion there. 1 cup is equivalent to 0.24 liters. And so now all I have to do is multiply, because you notice the cups units will cancel. So 3.5 times 0.24 will give me my number of liters. So let me pull out a calculator real quick. We're going to do 3.5 times 0.24, which gives me 0.84 liters. So 3.5 cups is equivalent to 0.84 liters, but one stipulation here, I cannot actually use this equal sign because we had an approximation for this unit conversion here. So I just need to make sure that I change my equal sign to an approximation symbol because we did not have an exact conversion here. This is an approximate conversion that we're doing. So 3.5 cups is approximately 0.84 liters. All right, coming back up to the top. Number 5 says to convert 150 pounds to kilograms. So we're going to start with the units of pounds. So 150, and it's LB for pounds. I'll write this over 1 since it's not already a fraction. I want to end with kilograms, so I'll put equals some number of kilograms at the end. And now we just want to make sure we put a unit fraction in the middle that cancels out pounds and leaves us with kilograms. So I put kilograms on top, lbs or pounds on bottom, and we have the approximate relationship there that 1 pound is approximately 0.45 kilograms. So then I can multiply across the top because my pound unit is going to cancel, and I'm going to be left with 150 multiplied by 0.45, which is 67.5. So 67.5. And again, because we had an approximation here, I need to change my symbol to be approximately 67.5 kilograms. Number 6, a medication is ordered at 2 milligrams per kilogram. The patient weighs 154 pounds. Convert the weight to kilograms and find the total dosage in milligrams. So we have a little bit going on here. A medication is ordered in 2 milligrams per kilogram. So 2 milligrams per, meaning divide, by 1 kilogram. And what we want to convert this to is the number of milligrams that we need. So we are trying to turn this into some number of milligrams. So we have to convert the weight in pounds to a weight in kilograms and then figure out how many milligrams we need to actually give this patient. So we first need to figure out, what do we do with this pounds? So if you want to find out how much medication to give someone, and you have milligrams per kilogram is how you order your medication, then you multiply that by the weight of the person. So if we multiply 2 milligrams per kilogram by 154 pounds, that tells us how many milligrams to give the patient. So what I'm going to do is multiply here, multiply by 154 pounds. So 154 lbs over 1 because we just want to make it a fraction. All right, so now notice all the units we have. We have milligrams over kilograms, and we have lbs on top, or pounds. But we want to end with just milligrams. So we don't actually want to cancel out this unit of milligrams. That unit is fine. What we want to do is cancel out the kilograms and the pounds in this problem. So what we need to do is multiply by a fraction that is going to have something on bottom to cancel out the pounds. So lbs on bottom to cancel out the lbs on top, and kilograms on top to cancel out the kilograms on bottom. So now we need this to be a unit fraction. So we're going to do 1 pound is equivalent to 0.45 kilograms. And now notice all the units are going to cancel, where we have kilograms cancels kilograms, pounds cancels pounds, and so our ending units will just be milligrams, and it'll be the number of milligrams needed for a patient that weighs 154 pounds. So within this, we can go ahead and find out how many milligrams are necessary, where notice we have to multiply numbers on top, but on bottom we just have a denominator of 1. So all these denominators are just 1, so all I have to do is multiply 2 times 154 times 0.45. So we can go ahead and work that out. 2 times 154 times 0.45 gives me 138.6. But I have to be careful again, because I used an approximate conversion, I need to change my equal sign to an approximation symbol. Okay, so whenever our conversion is approximate, we also have to make sure it's clear that our answer is approximate. But now what this means is that a patient that weighs 154 pounds should have 138.6 milligrams of this medication ordered for them. Because if it's 2 milligrams per kilogram, what we did is we, in the middle here, converted pounds to kilograms, and then you multiply kilograms by milligrams per kilogram, and that cancels the kilogram unit. So you multiply rates times whatever unit is on bottom, in this case milligrams per kilogram times kilograms, to get the amount of milligrams you need. But in order to do that, we first had to convert pounds to kilograms. All right, number 7. A patient drinks 1,200 milliliters of water in a day. Convert this to liters. This is probably one of the easiest ones we're going to do because it's very similar to the previous topic where we're just converting within the metric system. So we have 1,200 milliliters, and this is over 1 because we want to make it a fraction. We're trying to convert this to liters, so over here I'll put liters as my ending unit. And I'm going to go ahead and use the big L for liters instead of my fancy cursive L. Now in the middle, we just have to convert. We need the milliliters on top to cancel, so I'll put milliliters on bottom. And we want to end with liters, so I'll put liters on top. And we have the proportion that 1 liter is approximately 1,000 milliliters. This one is actually, should not be an approximation. Sorry, that is a typo here. This should be equals, not approximate, because liters and milliliters are both in the metric system, so that one does not need to be an approximation there. All right, and then if we do this multiplication, we have 1,200 on top, 1,000 on bottom, so this is going to come out to 1.2 liters is equivalent to the 1,200 milliliters we started with. So just 1.2 liters there. Okay, there's another you try. Go ahead and give that one a chance. I'm going to skip straight to number 8, and then I'll come back and go over the 2 you tries. So for number 8, we want to convert 570 cubic centimeters to cubic feet. So 570 cubic centimeters is written as 570 cm cubed, and we're going to put this over 1. And we want to convert this to cubic feet. Okay, so on the right side, I'll put feet to the power 3 for cubic feet. So now the important thing to realize here is that when you're doing the conversion, cubic centimeters, the cm cubed on top, is actually 3 cm's multiplied together. So I'm going to rewrite what this unit is equal to. This is 570 cm times cm times cm all over 1. So it's just important to realize that when we're doing these next steps, this is actually 3 cm's that we need to cancel out, not just 1. So as I write these unit fractions in the middle, I'm going to need 3 of them. Because if I multiply by feet over centimeters, where 1 foot is approximately 30 centimeters, this is good. I cancel out one of these units, where 1 centimeter cancels with the one on bottom. But notice that at the end, I need 3 units of feet multiplied together, because feet cubed. And right now, I've only canceled out 1 centimeter, so I have 2 centimeter units still there. So I need to keep going. I need to actually multiply by this same unit fraction again. So I'll do 1 foot per 30 centimeters again, and a third time, 1 foot per 30 centimeters, where now cm's on top cancel cm's on bottom. So I'm left with no more centimeters on top, and I'm left with 3 units of feet multiplied together, so that'll give me my feet cubed over here. Now the math for this one's a little bit harder because we have 570 on top and 3 30s on bottom. So when I put this into the calculator, I just have to make sure I'm a little bit careful. I'm going to set up a fraction with 570 on top, and in the denominator, 30 times 30 times 30. And this comes out to 0.021. So I'm going to round this to be 0.021, where the 1 keeps repeating. So I'll write my answer as a 0.21 with a line over the 1. And I have to change my equal sign to be an approximation symbol here because this conversion was not exact, because 1 foot is approximately 30 centimeters, but also I technically was rounding my answer here. Now, because I use the bar over the 1 like that, that means the 1 keeps repeating. That makes it so in reality my answer is not rounded. The 1 shows the reader of this that that 1 keeps going forever. But because we had this approximation for our unit conversion, I still need to put the approximation symbol for my answer. All right, so now the 2 you tries. If you did not pause yet, please do that real quick. All right, hopefully you gave them a chance. So the one on the left, it says we have 8 cups per day and we want to convert to pints per year. So I'm going to start with cups per day. So I'll write 8 cups on top and 1 day on bottom. It's cups per 1 day. And we want to convert this to pints per year. So for my answer, I'll put pints on top and year on bottom. And when it says pints per year, really we want pints per 1 year. Okay, so when we use that unit, pints per year, it's pints per one year, not pints per plural years. Just like cups per day is cups per one day. Okay, so now in the middle, notice cups and days both need to disappear. So in order to cancel out the cups, we have the conversion up top that 1 pint is 2 cups. So since cups is on top, I'll put cups on bottom in my unit fraction, and I'll put pints on top. So now I put 1 pint is equivalent to 2 cups. And for years, we have that 1 year is the equivalent to 365 days. So since I had days on bottom, I'll put days on top, and I'll put years on bottom, where 1 year is 365 days. So now when we work out this multiplication, on top we have 8 times 365. On bottom we have 2. So all we need to do is multiply 8 times 365 divided by 2. And that's going to give us 1460. So this comes out to 1,460 pints per year. Wow. So if you're drinking the amount of water per day that's recommended, which to my knowledge is still 8 cups per day, that means you're drinking 1,460 pints per year. Huh. Fun to look at that way. All right, last one. Hopefully you gave it a shot. A nurse must administer 1,000 milliliters of IV fluid over 8 hours. What is the flow rate in milliliters per minute? So we are starting with 1,000 milliliters over 8 hours. So 1,000 milliliters divided by 8 hours is our unit. Okay, because over the course of 8 hours, we're doing 1,000 milliliters. Now, we want to convert this to milliliters per minute, which is actually not going to be too bad because milliliters is the same in both cases. So at the end, I want milliliters on top, which it's already there. I just want to convert hours to be minutes as my new denominator. So in the middle, the only unit I'm worried about canceling is the hours. I want to end up with minutes on bottom, so I have to put hours on top to cancel out the unit of hours. That is going to give me a fraction of 1 hour is 60 minutes. So then all we have to do is reduce things here. We're going to have hours canceling hours. On top, we have 1,000, and on bottom, we have 8 times 60. So we're just going to work it out. 1,000 divided by 8 times 60 comes out to approximately 2.083, where we'll put a bar over the 3. So 2.08, and the 3's keep repeating. So we'll leave our answer there as 2.083 with a bar over it. And that is the number of milliliters per 1 minute. So 1,000 milliliters over 8 hours is equivalent to 2 milliliters per 1 minute. And if we wanted to go backwards, we could, of course, multiply it out, where 1 minute times 60 would get us to an hour, and then times 8 again would get us to 8 hours. So if we multiplied our milliliters per hour by 480, that would actually get us back to the 1,000 milliliters unit over 8 hours. Well, that has been our lesson on dimensional analysis. Hopefully you had fun. I think this is actually one of my most appreciated topics. And if you did not have it in your booklet, I encourage you to now use your dimensional analysis skills to generally what I give to my students on the first day of class is a conversion from screen time on their phone. It starts off, your phone gives it to you in hours per day, and I have them convert that to days per year. So I encourage you to find your screen time on your phone, go to settings and go to screen time, find what your daily average is, and convert it from hours per day to days per year. That way you can know how many consecutive days of time you spend on your phone in a year, and I bet you it's probably more than you think, and hopefully it makes you rethink your connection to your cell phone and maybe go outside and touch grass. And that's how I'm going to end this one, guys, is go outside, touch grass, stay off your phones. Much appreciated. See you guys next time.